I'm Alfredo, and today I'm going to tell you about smashing galaxies. So, first a little bit of... there wasn't that animation there? Okay. Stating the obvious. Galaxies are very big, and they're usually very far away from each other. You can have two main types of galaxies. They're either spirals, like that, or an elliptical like the one that was running away there. Spirals have nice regular structure, ellipticals have a bit more of a mess, but you have stars going around the center. Since astronomers are very resistant to change, they decided to call the spirals, which were the first formed in the universe, late type, and the ellipticals, which are the one that formed later, early types, because that's what they thought. That's how they thought they formed back when galaxies were discovered in the 1920s. Something that is not too obvious is that galaxies actually move a lot and they interact a lot. And the talk is going to be how the galaxies interact and why they interact. Galaxies are not randomly put into the universe. They are distributed around big dark matter strains. Dark matter is a little bit like the Force. It's everywhere, it permeates us, and using midichlorian to explain dark matter is pretty much equivalent because nobody knows what it is. If you heard of galaxy collisions before, galaxy mergers, you've seen these pictures. This is the antenna galaxy. Google galaxy mergers, you see these pictures because they're pretty. They're two spiral galaxies, they're forming a lot of stars, and they're a major merger because they're pretty much the same size, and everyone used that because, oh, look, they're so pretty, oh, use that one, everyone loves that, wants pretty pictures of galaxy mergers. Instead, if you want to see what I study, you need to look for the lumpy stuff that nobody cares about. This is the Whirlpool galaxy. Perfect example of spiral. You see nice, well structured. Most of the time I see the picture cut there because nobody cares about the big lump there. That is a dwarf elliptical galaxy that is slowly merging with Whirlpool galaxy. It doesn't even have a real name because it's called M51b. No importance at all, but we can change our point of view, and that's what it's all about. If you look at it in X-rays, suddenly you see that the situation is a lot different. You have every big bright spot is a black hole. So you see that this galaxy is really active. Obviously it's the big one and has a big supermassive black hole. But even the tiny one, it's got a huge supermassive black hole at the center, got a few black holes here and there, and there's a lot of, all the diffuse light is hot gas, being either emitted by powerful stars, supernovas, or other black holes. And what they found out just last week is that here in the tiny M51b, you have two big bursts of gas emitted by the black holes because it's been feeding for millions and millions of years. And this, in front of this sort of moon-shaped, half-moon-shaped gas, there's new stars being born. So the black hole, the supermassive black hole that is there to destroy everything, usually, is forming new stars. So M51b should be the M51 merger, and because they are equally important in activating the star formation for both the dwarf galaxy and the big spiral galaxy. So that's what happens. You have two galaxies that come together and they completely change what's going on inside and their shape. You have spirals that eventually will develop into the ellipticals. So the late types becomes early types. And you have star formation and you have a big black hole. Everywhere. It's the bluest part, you can't really see it. It's the near infrared, the reddest part is far infrared, and the entire galaxy is shining with new stars. And this is important. We think that galaxy mergers in the early universe, so in the first 3 to 5 billion years of the universe, were driven by galaxy mergers. Now it doesn't really happen anymore because the universe is much bigger, galaxies don't really want to see each other much, but it's still happening. But there's something else. Galaxy merger doesn't only form new stars, also kill stars. Because when supermassive black holes get activated, start releasing a lot of gas through processes that goes around the event horizon. And they start emitting, this gas becomes galactic white winds. So you see this galaxy here, which is a bit lumpy and is the kind of galaxy that I study, is about the size of the Milky Way. And these are the emission of the gas from the black hole. You can see that from here to here is about 5 million light years, which is even further than our closest galaxy, well, our closest big galaxy, that is Andromeda, that is only 2 million light years away. And these galactic winds completely snap out any star formation. They heat up the gas and suddenly you don't have any stars, because very counterintuitively, you need to have cold gas to form star, because the gas needs to condense. So this is the core of my PhD research, understanding how you go from your merger to relaxed galaxies. So you know that you have at some point star formation, and at some point you have the AGN activity. The AGN is the black hole, the active galactic nuclei. But we still don't have any clues in where is the peak, because we find galaxies that have a lot of star formation, no black hole activity. Galaxy with a lot of black hole activity, no star formation, and we see a lot that have both. And we know that star formation happened first, AGN happened later, but we don't know exactly when things peak. And we're trying to do simulation, but it's very difficult because galaxies are big and messy. Something that we can understand, though, is how you go from the nice spirals to the elliptical. And that's what I've been focusing on, looking at the missing links between the spirals and the ellipticals. You go from, first you have a nice merger, things go around, you might have some flyby first, few passes, and then things become closer together. You still get some bits of star flying off, but it's already looking at a lot more lumpy and spherical. You get a sort of spheroidal post-merger. Now in Hubble you can see that there's a lot more activity. When you see it with simpler telescope, you just see something here and say, sort of round. I'll accept that it's spheroidal. And eventually you end up with a very special class of early type galaxy. There are blue ellipticals, which are elliptical that are not elliptical just yet, but they still have a lot of star formation, a lot of gas, a lot of dust. And they are the sort of last array before a galaxy becomes elliptical, and it's just a bit red and dead. And eventually you think, okay, this is all nice and interesting. Why we should care? My grandma constantly asks me that. She is still upset that I'm not a medical doctor. And I keep pointing out to her that eventually we need to care about these galaxies, because that's our future. We are in a nice spiral galaxy, but we're not going to be in a spiral galaxy forever. What's happening is the Andromeda is slowly but surely coming towards us, and it's going to merge with the Milky Way and completely change how the Milky Way is and what our sky looks like. And I've made this, well, oh no, quick, sorry. Let's see if it works. Easier to explain how it works. Robert is there, and that is our tower. There's dragons. So Andromeda is getting closer and closer, and it's just going to appear cleaner in the sky, and then you have star formation, supernovas, things going crazy, alien city. the sky is going to look like. No more Milky Way and just random stars going around the center. So the moral of the talk is that you can have thin galaxies. Yes. Thick galaxy, blue, red, yellow, regular, irregular, and messy galaxies, but they all need your love. So the scientific conclusion is that the galaxy mergers are a fundamental mechanism for galaxy to evolve. For a billion of years, the late types, the spirals, collide and turn into ellipticals or other late types. It's a long process. And it was not going to stop. Galaxy will continue to merge until there are galaxies in the universe. The universe eventually will expand that until there's only one galaxy in the universe. But until then, merger will be a star will be born in mergers. There are going to be supermassive black holes, and galaxy will continue to evolve. Thank you very much. I'm not in academia anymore. I work for fucking Love Science and I write scientific articles.
Thank you for that. Taking a long view. Has anyone got any questions? Yeah.
The simulation, when doing simulations, is that?
It wasn't a simulation. It was mostly. So somebody made a simulation about 4 years ago about what would happen to the solar system if when the Andromeda merger would collide with the Milky Way. I was giving a talk at the Royal Observatory in October, and I wanted to use that, so I contacted the researcher, and they said that they only had screenshots, and I wanted to have something a little bit more active because it was aimed at GCSE student, so I wanted a little bit more active. So I asked my partner to do a little bit of graphic design, and it's from Wales, so he added to it was like. I'm either putting a dragon in it, or you're not going to have the video. So it's, I just assumed what you would see. The final part, when you see the two black holes coming together, is as close as the simulation you can get. The other is just picture of other merger in a sort of way what you could possibly see. So it's highly speculative, and there's a lot of 3D. Put some bright flashes here. So.
if like you were living on a planet going around a star that is in a galaxy that's smashing together, genuinely, like, would planets survive that if it was a star being ejected, or?
The simulation that they made 4 years ago, they said that the sun is still around in a billion times. There is an 80% probability that the sun will be unaffected. We'll just move on to a different orbit around the Andromeda Milky Way system. There's, I think it was 9% probability that we would be too close to another supernova and the sun will be destroyed by that. And there was, I think, tiny probability that the sun would be flung out by the system. Mergers are very, very slow, as you can see, as the time would progress, and they don't tend to affect stars, apart the galaxy-wide winds and apart supernovas that happen. So, good chances for stars to survive. I'm not sure chances for life to survive.
If it won't come up, I can talk without.